Yeah, please, some of you at least turn on your video. Saina
Yeah, sure. Yeah.
and some more. Siddharth Solangi. Yeah, those who said that they have very good connection. Hello.
Hello.
Yeah.
Yes, sir. My Wi-Fi is down, so I'll not be sharing.
Okay, no problem, no problem. Those who said they have very good connection. I know many of you have at least half the classes have very good connection. It's fine. Even if you are not sitting up well upright, it's fine. I just need to see your face. Even if you are lying down, it's fine. Please. Okay, we have to start. All right. So I have asked you to read 1.1 and 1.2. Can you remind me what are the major ideas in 1.1 and 1.2? Saina, your audio is mute.
Yeah, it mainly started with about primitive data and then
Yeah.
means of combination.
Okay.
And then it went through abstraction, like
Yeah.
defining functions, like
Yeah.
naming things and all. And
Yeah.
then after that, it gave some examples, and then went through tail recursion, like the difference between recursive process and
Yeah.
iterative process,
Yeah.
uh, with the example of factorial.
Yeah.
They are also specifying what is tail recursion and all, and
Yeah.
then they are going through mm, and then yeah, and then they are using another example, like Fibonacci example, explaining about tree recursion.
Yeah.
Yeah, and
So basically in the first 1.1, what you are seeing is the basic flesh and bones of the language. Yeah. In the sense that what is the elementary syntax of this language, and what is the primitive elements of the language, and how do you make complex statements. Yeah, any language, remember, any language, even natural language, you specify the same way. You actually enumerate the basic elements in the language, and then you say these are the means of composing simple statements to get more complex statements, and then but and or and things like that. Yeah. Similarly, they start with 1.1. They start with the basic types of the language, and then go into this one. Second, in the 1.2, what they are discussing is about the difference between procedures and processes. Procedures are the source code you write. Processes are things which you have when that procedure is run. Yeah, and the evolution of a procedure is called what they call process. It's not very common that people this kind of it's not a very standard name, procedure and process, but they want to focus on the paradigm of language. That's why they bring about these notions. Okay. All right. So in last class we saw the tail recursion. Last class we also saw the basic some basic Lisp. Now in this class I want to focus your attention on something which is there in 1.1 at the end of the section 1.1. Okay. Can somebody remind me the square root function? The square root function was defined like this: define square root of n. Let's call it x. Square root of x was, what was the function? It was an if statement. If, can you remind me? There was a Boolean predicate good enough.
Uh,
No, square
no,
root
it was
function has two
actually
more
using.
arguments.
Yeah.
Yeah.
Function.
One was guess and the other was improve. Yeah. Did you do this thing? Was this in yeah?
So
No.
there were two main functions. One was square iter to calculate the square root by iteration, and
Yeah.
square root which calls the square root iter in and takes the x as input. So sir, what you have written was for square iter, and it does not take any argument as improve. Improve was a function which it
Yeah.
calls. So may I tell the function?
Yeah.
So
Okay. So it has only just square root x
and
and guess.
yes sir.
Okay. Square root iter x and guess. And then if
So
good enough.
guess and x are the parameters,
Yeah.
and then it will return guess if true, else if
True.
true.
No, it has to
So
get
x,
return guess. It
yes
has to return guess
yes
if it
sir.
is good.
So yes sir. Then square root iter, else
Otherwise,
square root iter, improve guess x and
improve is a
x.
function.
Yes sir.
Guess and x.
So x before because you have written x before guess now. So sorry sir.
Okay. Yeah.
X then guess. No
This was
sir.
a function.
X improve.
And yeah.
Yes sir.
And good enough guess x was we find the absolute value.
Yes.
We have again an if statement. If
Yes sir.
abs of
Minus
The
square
difference is
root
less
guess.
than 0.
yeah
Yes sir.
square of x or
And x is less than 0.001.
no, it
Dif-
is a difference
so
between x and
absolute
square of yes. Yeah.
yes sir. So minus, so after absolute there should be minus difference
Minus
between.
yes.
Yes sir.
X and square.
Yes sir. So square guess
Square guess is
less
uh,
than 0.01001.
and there has to be a less than here.
Yes sir.
So square of guess minus absolute and 0.0.1. If that is the case,
Yes sir. So it will return true accordingly. So no need to do sir anything. So it will
this is
return
a
0.
Boolean value.
Yes sir.
This is a Boolean value. So I can get rid of this if statement.
Yes sir.
Okay. So that's a Boolean value. So good enough is a Boolean function that returns if that returns whether the square of guess and x, the absolute difference between square of x and guess, no, square of guess and x is less than 0.0.1. And the other function was
Sir, improve guess function was define improve guess
the
and
improve x guess
x and
was
guess. So
was
average of
average
guess and sir x by guess. Yes, sir.
range of
X and x by guess and x by
x
guess.
by
So
guess.
slash x guess.
Yeah.
So then the average function.
Average of x and y will be
Yes, sir. So division.
divided by plus of x and y by 2. And one more function is define square n is
Yes. Sir. So which calls square root of.
pardon?
Yes, sir. So yes, sir. And one is square root. Define square root.
Square root is
And
where is square root?
so to call square root. So for square root, we give our input as number, na.
Yeah.
2.
Square root,
So
yeah.
square root.
SQRT will be SQRT iter 1 x and 1.0.
Yes, sir. So one more thing, it takes input argument as input x. Define square root argument will be x.
Yeah, sorry. Yeah, I should start doing this thing.
Sir,
Yeah.
in line number 6, square root iter takes 2 arguments. So we also need to pass x. Line number 6.
Yeah, 1 second. Let me try to do it in Racket so that things become easier. So since we don't have line numbers now, it might cause problems. In line number 6,
Line 3rd from top in the code.
void iter improve.
In square root iter, we need to pass x and
X
improve
also.
x of s.
Yeah. Okay, let's try XQRT of 3. Okay, it comes now. But is it the library function? I don't know. SQRT iter of 3 and 1.0. Okay, it's coming fine. All right, so this is a function. Yeah. But now one problem is that, so you might have seen this thing in the 1 section end of 1.1 also. We have all these helper functions. Yeah. We have the main function square root iter, and these are all helper function because these are all appearing somewhere during this execution of this original function. And so if we are, imagine if we have a program with 20 functions, and then each of these 20 functions will have some 30 square helper functions. So it becomes very difficult because it will be scattered. So it will be nice idea to collect all the helper functions along with their mother function, yeah, with the parent function. And this was the improvement which Scheme, one of the improvement which Scheme made on Lisp. So what Scheme said is that, okay, let's come here and we have the function and body, but before that, let's try to pack all these functions within the scope of this function. Okay. Except SQR. So I am pretty printing just to SQRT iter 3 1.0. Yeah. So what we have done is that we have packed the helper functions within the original function. Should be here. Just pretty printing. And now when this function, this body of this function, the body of this function is these lines. So when this function calls good enough, it is actually here. With this function calls improve, it is here. Okay. And now we can make actually one more adjustment, which is that these functions are within the scope of this original function, square root of iter. And therefore, this function has this binding x. So this x is going to be bound, BIND, BOUND, which means that bound means that whenever a value is attached to a variable, that is when what we call a name is bound to a variable, bound to a value. So whenever I call square root of 3 1.0, 3 is going to be, x is going to be bound to 3 and guess is going to be bound to 1.0. Yeah, that is how function call happens. So since x is already a variable which is bound to the which has a meaning in this context, I can get rid of this x from these functions. Okay, so I'm going to change. Now this x has to remain the same. Okay, and I can remove it from this function also. Good enough. Okay, so what I have done is that I have simplified this function good enough and improve by just eliminating this x from their parameters, because since these two functions are within the lexical scope, so I need a I'm going to introduce a new word, lexical scope. Today is 9th. So lexical scope. So what is lexical, the word meaning of lexical? Any idea? You might have heard some associated with lexicographer.
The reference to text.
Yeah, lexicon means text. Yeah. So what does lexical here refers to? Lexical means text. Lexicographer is somebody who deals with the text. A lexicon means the words you use in a language. Yeah, it is not in the lexicon of something. When you say like that, it means that it is not in the vocabulary. Yeah. So here, when I mean lexical, what does it mean? Refers to? Any idea? Any guess?
So the written portion of the code.
Exactly. It refers to the source code. It refers to the source code. So when I say that this function is in the lexical scope of this one, it actually means that I can look at the source code and I see that this function is within the scope of this function. By examining the source code, I get to know what is in the scope of what. That is what I mean by lexical scope. Okay. By examining the source code. So therefore, this function is written within this function. Therefore, I would say that this function is in the lexical scope of this function. Therefore, x will be accessible here. So therefore, I can use this x without getting it as a formal parameter of this function. Similarly, this x I can get without getting it as a formal parameter. Yeah. So therefore, I simplify function, my function. Okay. So this is the idea of lexical scope. Lexical scope is also known as static scope. Static scope, meaning the scope of a name. So whenever I mean a name, it could be an identifier or a variable name or a function name. All are names, function name, module name. These are all names. Yeah, the scope of a name is determined by its lexical context. In other words, by examining the source code, we can deduce the corresponding, the binding of a name. What do you mean by binding? Binding means that when I have a name and the name corresponds to something. Yeah, in programming languages, you have so many names. You have names corresponding to variables. You have names corresponding to functions. You have names corresponding to macros. you have name corresponding to expressions, a whole lot of things. Yeah. And corresponding to every name, you might associate an expression or a function or a block or many things. Yeah, it could be a label, so many things. And this association is called a binding. Okay, that's a formal name for this association of name versus object. That is called a binding. Okay, so lexical scope means that to understand what does something corresponds to, I just need to look at the source code. Okay. Now, what is actually scope? What is scope? What is scope? What is scope? Okay, the standard definition of scope is the extent to which a name binding is the portion of the program to which a name binding extends. Okay, what does that mean? That means that if I have a name and I look at that particular name and to which extent the binding of that name extends to, that is what we call a scope. Okay, so we already know one kind of scope, which is static scope. So what does static scope means? Static scope means that whenever I have a name and I look at the source code and I get to know what is it. In other words, static scope static scope can also be stated as scope reduced at compile time. Okay. Now, what do I mean by that? Let's take an example. Okay, I have a function. Okay, this is my function. So I have the x equal to 0 defined globally. I mean, at the outermost scope. The outermost scope is what we typically call the global scope. Yeah. I have x equal to 0 defined. And then I have a function f, which just prints x. And I have a function g, and which says x equal to 1. And I have and that function g calls f. And then the program just calls g. Now, what will be printed? What will be printed?
0.
Yeah, what will be printed? All languages after Algol prints 0. Okay, but Lisp used to be a language which used to print 1. Okay, Lisp was originally made in 1957, and at that time Lisp used to print 1. And what is the reasoning behind printing 1? Can somebody tell me what is the reasoning behind printing 1?
Dynamic scoping.
Yeah, dynamic scoping. But can you explain a little further? What do you mean by dynamic scoping?
During runtime, the value of x is, I mean,
Yeah.
Yeah.
During runtime, the value of
Runtime.
X is. So
Uh,
actually, what you're saying is that whenever the command says print X, and at that point at runtime, I'm keeping a list of bindings. Okay, what does X corresponds to? What does Y corresponds to? Etc. I'm keeping, and at runtime, I just look at the latest binding of X and I print that. Okay.
yes, sir.
So that is what we mean by dynamic scope. Dynamic scope means scope is name binding is determined at runtime. Okay. So runtime means that at compile time you can't specify. There is no way you can specify this one. For instance, if I have okay, now you know that you have studied in theory of computation that it is not possible to find whether the value of X will be 1 or 2 from by a program. Yeah, because you learn something called Rice's theorem in theory of computation, which said that any non-trivial property of a program cannot be. Have you studied this in theory of computation? But at least you know that checking whether a program terminates or not, yeah, or checking whether a value of a variable is 1, etc. These things cannot be found by programs. So therefore, if I run this program, G, what does it do? It calls some arbitrary part of the program, and once it does, it returns a true value, it puts X equal to 1. If it returns a false value, it put X equal to 2. Now, if my scope is dynamic, yeah, I mean, if my scope is dynamic, then there is no way apart from running the program itself that I will know what the value of X is. Only by running the program, I will know whether X should be 1 or X should be 2. At compile time, I can never know if my scope is dynamic. Is that point clear? Questions? So in essence, the scope is the portion of the program which extends to which a name extends. Now, what are the kind of scopes in C programming language? Hello. In C programming language, how is scope managed? Somebody?
So do you mean the global scope and local scope?
Yeah. What all things would start a new scope in C programming language? What are the rules associated with C programming language?
The loops, functions.
Yeah, loops start a new scope. Whenever I put, yeah, if I have f index, and if I have for int x equal to 10, yeah. So now what happens is that I'm going to yeah. So this is a function in C. It's just a function f. That's just to be clear. Void is not in there in C, I guess. Okay, I have a function f and it says index equal to 20. And then I start a loop which says that for a int x equal to 10, x greater than 20, x plus plus, and then print of x, and then again print of x. So what will be printed? Can't hear.
Nothing, because x is greater than 20. So you have to put x is less than 20.
Yeah. X is less than 20. And what will be printed?
10 it will print first and then 20.
10, 11, 12, all the way up to?
Yeah, yeah. 20.
All the way up to 20 it will print, and then what it will print?
And then
Okay, maybe I should change this 20 to something else. Okay, what will print afterwards?
30.
It will print 30. Yeah, because there are two scopes involved here. One is this outer scope. This is called the function scope. How do you put comment in C? How
So
do you put comment?
double backslash.
No, slash star. Yeah, slash star. Function scope. Yeah, this is the function scope, and then this is the block scope. And if I have int x equal to 40 here, this is the global scope. Yeah, so we already see that in C there are 3 layers of scope. There are more layers of scope in C actually, because you could put macros and you could put yeah, you don't have namespaces in C. So you have already at least three layers of scoping. That I can have the outermost layer, I can have one name, and then inside I can have the same name with a different value. Inside that, the same name, a different value. Yeah. So I can have 3 different scopes, block. And with one special thing about C is that in C, the variables start existing only after it is declared. So if I say print here, in C it will complain. Yeah, because it will complain saying that x is used before it is defined. So even within a scope in C, what happens is that the variable can only be used only after it is defined.
Sir, in this
Yeah.
case, doesn't the value 40 prints if we print x before defining int x equal to 30?
Yeah. Actually, since x is there, it will. Yeah, it is true. I mean, I confused. So in this case, the global scope will be. The global scope was not there. I forgot about the global scope. Yeah. Okay. Now, what is this definition? What is this index equal to 3? That is another use of the word. It is called statically typed. What does this mean, statically typed? What does statically typed means?
Sir, it means that the data type of all the variables are assigned at compile time.
Exactly. Means that types of names or variables. Let's call it names, okay? Because we have been using names. We will be using names all along. But names can be are not just for variables. Names are also for functions, also for a lot of expressions and a lot of other things. Yeah. So programming languages typically assigns types not just to variables, but all kinds of names. So we'll use names. So means that types of names are assigned at compile time. Compile time. Or we could also say it this way, or we could say that types of names can be deduced can be deduced by examining the source code. Okay, because that is what you are saying about compile time is exactly the same thing, because there is a program which actually looks at the source code and actually deduces the types of the variables, types of the names. Yeah, so that is what is statically typed. Now what is a dynamically typed language?
Sir, it means that the data type is assigned at runtime, and it can even change from one type to another during runtime.
Yeah, can you give me an example of a language?
So for Python, in Python we can change the type.
Python is dynamically typed. Dynamically typed. What does that mean? That means that types of names are reduced at runtime. And in fact, it is not possible to reduce the type of the variables during compile time. For instance, I could do something like this. If do something, then so in Python it is like this. If do something, then I have a colon, and then I would say x equal to type some type else x equal to some other type. Okay. Now again, by appealing to the theory of computation theorems, which says that you cannot write a program which will tell me what is the value of x after this code is executed. That is one theorem which you learn in theory of computation. Yeah, without running the program, you can never know what is what one particular value will be, when variable will be assigned. So therefore, if I have this piece of code, to know what will be the type of x, I have to actually run the program. And in compile time, you're not running the program, you're only translating the program, you're not running the program. Okay, running the program is done by an interpreter or when you execute the program. So therefore, yeah, everybody understands the difference between compilation and interpretation. Hello. What is the difference between compilation and interpretation? Somebody?
The compilation is translating the whole source code at once into a machine language, and
Yeah.
interpretation is line by line or statement by statement.
Yeah, it's a interpretation is like executing the program line by line. Okay, and compilation is translating the code into another language. Yeah, need not be a machine language, because these days most programming languages do not translate the program into some low-level machine code. Only for instance, in Java, for instance, they don't translate it into a machine level code. They are translate it into something called Java bytecode and executes there. Closure, this the famous Lisp dialect Closure, that also compiles it into Java so byte code. And so it is very much interconnected. That is what the J of closure is for. J is for Java. Okay, so this is what is, so today we learned the two main words, static and dynamic. And the static and dynamic, in one sentence, static means that at compile time, dynamic means that at runtime. So the statically scope means that the scope of a name I can actually know at the compile time, and dynamic means that the scope of a variable I cannot know at only can know at runtime. Okay. Similarly, statically typed means that the type of variable I can know at compile time. Dynamically typed means that type of a variable I can know only at runtime. Okay. Now let me also say one more thing, that we might think that dynamically typed. Okay, I didn't finish what I was saying about the dynamically typed variables. So dynamically typed variables was in use, for instance, in Lisp and languages prior to Algol. Algol first came up with this idea of block structure. The Algol language looks exactly like C. Okay, C is a logic intellectual descendant of Algol. So from Algol came a language called BCPL. From BCPL came first B and then came C. Okay. So Algol introduced this idea of blocks. So with that is, you put curly braces among between statements or programs, and so that it actually, the control flow is neatly. You don't need the go-to statements. If you have programmed in Fortran or programmed in BASIC, you would know that instead of this block structure and for loop and while loop, you would use go-to statements and do statements, etc. If you want to program, which is not very nice, because you come down and then it says go to some line, and then you go there, and then it comes there down, and then there is an if statement and it says go to this line and so on, which is not a block structure, because things could be like this. Okay. Yeah, what I'm saying is that if I say so this is the line label 10, this is the line label 11, this is the label 12, and says that if something go to 12, and then here I say if something go to 10, and if 11. So this program does not have a block structure. Okay, because it says you cannot neatly pack this code into blocks, because it is all completely interconnected. So Algol said, no, let's not do this. Let's use only blocks using if statements and while statements and for statements, and that will packs everything in nicely into small boxes. And that boxes is what we in C we write in curly braces, and in Python you write it in same indentation. Okay. So that was not text. Once you have block structure, then scope is immediately clear, because every block is a scope. Yeah. And function is a block, and within functions there is one block. There are loops. That's another block. Within every two curly, within a curly opening brace and a closing opening brace, you have a scope, and so on. So since then, most of the imperative programming languages are those programming languages where programs are executed in sequence. This. But we already saw that Lisp is not imperative, in the sense that it is more like functional. You are not saying you can write the program in any order, and there is no clear sequence of operations. Is that clear what I mean by sequencing of statements?
The imperative programming is not clear to me, sir.
So imperative programming is this. When I say 10, 11, 12, what I mean is imperative, because you have this source file. Okay. And the C programming language says that this is how you execute the program. You take the file, you first find a function called main. You go there, and then you execute the first line of main, then execute the second line of main, then execute the third line of main, then execute the fourth line of main, and so on. Okay. And the fourth line of the main function might say, call this function and return me this value. And then I go to that function, and then I start executing the lines one by one by one. Okay. So it is like the program is telling the machine to do, is giving commands one after the other. That is what is called imperative programming. Okay, but in the case of Lisp, we see that our functions are of this form. We are actually writing expressions. Okay, what are our expressions like? We are defining, this is the expression, square root of x is the expression times x. Average of xy is the expression division division sum of xy and 2. Yeah, x plus y by 2. So I'm saying this is the expression, this is the expression for this is the expression for this, and so on. And then I say, to get this value, you just start substituting. Okay, so I say that to find square root iter of this, find square root iter. Then what you are saying is that I look at the expression for square root iter and then I substitute that. Now within that square root iter expression, there is some other expression to substitute. So I substitute that and I substitute next and next and next and so on. Yeah, and the idea, the fundamental operation which I'm not doing is not following a sequence of steps, but substitutions. Isn't it?
Yes, sir.
Is it clear? The
Yes, sir.
difference between, so it's not instead of following commands one after another, and these commands are modifying parts of the memory, or basically they are changing the state of the machine, state of the memory. That is what is happening in imperative programming language. But here we are not changing the state of the memory. We are actually expanding or substituting expressions for expressions. That is more like functions. That's why it's called functional programming. Okay, because I can always substitute an expression for another expression regardless of what context it is in. Yeah, regardless of what context it is in, I can always substitute average of xy. I can substitute it by x plus y by 2. Okay, it doesn't matter what x, y are, in which context it is. But in the imperative programming language, it is not true. I cannot substitute one function for another function. I mean, whenever this function is there, I cannot substitute, because there are all these problems of scopes and global scope and local scope and all these things. Okay.
Yes, sir.
I hope it is clear. But as you gain more experience with programming languages, these ideas will be more thorough. Okay. Okay. So today we learned these two words, static and dynamic, and statically typed and dynamically typed, statically scoped and dynamically scoped. Okay. Let me also tell you that statically typed does not mean that you have to put the type of everything. In Python, you never write a type. You never say index or char y and fix that. Okay. In C, you always have to write this one. Now, there are languages where something in between is allowed. Okay, that is called type inference. For instance, if I ask in Haskell, okay, in Haskell, I'm going to define a function add xy. I'm going to say add xy is x plus y. Okay. And if I say what is the type of add, it will tell me type of add is any it is any numerical type. Num stands for any numerical type, and it takes two values, a of type numerical, and then gives me back another a arrow, a arrow. Okay. Okay. So I didn't tell Haskell anything about x or y or anything, but Haskell deduced it because Haskell has type inference. Okay, type inference. Type inference means that the type will be deduced. So even though Haskell is a statically typed language, we never have to tell what is the type of we almost never have to tell the Haskell what is the type of something, because Haskell will deduce it, even though it is reduced at compile time. Okay. Okay. So that is what is function scope and this one. Now there is one more thing which is there in your. So let's come back to this this code. So we've diverged from this point that scheme is actually lexically scoped, in the sense that you can actually nest functions, and the nested functions can actually use the variables of the parent function. Okay, and that is that is something which is not there in Lisp. Okay, now there was one more thing called lambdas. Now, can somebody remind me what lambda was there introduced now in section 1.2? Hello? Remember lambda? Hello? Hello? Can't hear, Saina.
Yeah, it was actually introduced in that first video of MIT video, but I'm not sure if it is introduced in that 1.2.
Oh, it is not introduced in 1.2. Okay, let's introduce them. What are lambdas? You would say this lambda expressions in pretty much almost all major programming languages these days. Okay, it's there in Python, it's there in Java, and all kinds of, but it's not there as general as in functional languages. So what does lambda mean? So this lambda comes from name lambda comes from lambda calculus. Okay, lambda. So we will talk about lambda calculus at some other day, and not today. So lambda calculus was introduced by Alonso Church, and it was the first programming language. You could say it is the first programming language. He brought before Turing machines was introduced as a foundational tool for computer science, because currently we use Turing machines as a fundamental model of computation. Alonso Church, before Turing machines, Alonso Church proposed a fundamental model of computation, which is lambda calculus, which is a very rudimentary programming language. There are only 3 rules of lambda calculus: function abstraction, function application, and lambda abstraction, function application, and just variables. Okay, these are the just 3 rules of lambda calculus. And then it's a very elementary programming language, and he said that whatever is computable using this programming language is whatever computable functions are. And then at that time people didn't accept that because it seems too rudimentary. And then Church was actually doing his PhD under Turing did his PhD under Church, and Turing came up with this Turing machines, but only after we came up with the Turing machine, he went Alonso Church to do his PhD. It's a fact. And Turing machines became very popular because that's more in tune with our intuitions about how computers work. Even today, when we talk about programming languages, we talk about programming languages as something where we change the memory cells and we assign values, we add something, subtract, loop iterations, and so on. We are not attuned with the functional paradigm. Okay, most programmers are not. Most programmers prefer the original imperative model. They don't prefer the functional model. But actually the functional model is clearly superior to the original imperative model. And so the in lambda calculus, you don't have these names. So so that's a question which I wanted to ask. What is the purpose of scope? Why do we need scope? Why do we need these scope rules? And why do we need typing? First of all, why do we need types? Somebody?
Sir, if there are operations that are being performed, there should be no ambiguity as to how it should be evaluated.
Yeah, but in Python, there are all kinds of ambiguities, no?
Sir, memory allocation may be thoda help.
Yeah, it will help in memory allocation, that I agree. But there are, as you saw, that dynamically typed languages don't really care. You run the program and then you know, so yeah. So you are still talking about from the machine perspective. Typing is
Maybe
actually not for the machine. Typing is actually for us. Okay.
group a set of values or
Yeah, it is not about grouping set of values and so on. Typing is actually for us humans. Typing enforces the discipline of programming. Okay. And if you have statically typed, you can detect a lot of errors during runtime, during compile time. Okay. That is a fundamental reason why you say that this function returns this type, and therefore, and C compiler checks this function, you declare the type of this function to be this. Now when you come here, you're using this function, uh, whether the types match. Yeah, actually, what does the C compiler check? The C compiler checks if the call and return types of every function matches. This function is stated to return this type. This function takes this function as an argument, this kind of type as an argument. Does this two match? Yeah, this is what the C compiler is checking. Now, why does the C compiler check that? It actually helps the programmer immensely to discover his errors. So in fact, what you are actually doing is that most of the time you spend your time in debugging is actually checking the compile time errors, which are mostly type errors. And then this is also in your experience, compile time errors are much easier to fix than runtime errors. Yeah, when you were doing your data structure course and you were debugging some dangling pointer, and it gives you a headache because you don't know what is going on. Yeah, especially if you're coding some AVL tree or something like that, then you have all kinds of pointer manipulations and something goes wrong. It compiles beautifully, but then there is some error, you don't know what to do. Yeah. So the purpose of uh, typing is actually to help the programmer discover errors. Okay, that is what the purpose of typing, to discover, to make everything. And then there are all kinds of other side advantages, like you can know in advance how much size your program will take, what how to how to assign the stack frame, all kinds of things. But the main purpose is to to help the program, aid the programmer. But what is the purpose of scope? Why do you need scope? Why can't all the variables be in the global scope?
for memory management or something like if it
Yeah.
yeah, if it is in a block or if you are using a calling a procedure or something, you can actually use that space after the procedure is being called again for
So
other purpose.
you are saying that some scope is assigned in the heap, some scope is assigned in the stack. Yeah, essentially a C program has three code segments assigned to it. One is the heap segment, one is the stack segment, and one is the code segment. Okay, it's called data, heap, no, stack, heap, and code segment. Yeah, code segment is where your code resides. Stack is where your there's a function called data resides, and heap is where all your allocated data and all your um, global variables, all these things reside. Yeah, and heap grows in a stack. Stack grows in a stack fashion. Whenever a function is called, it puts a new stack on top and then executes this thing. Whenever the function is returned, it is eliminated and it returns to the previous one and so on. Yeah, but that is true. But that is how C is arranged. But what about Python? What about Java? Or what about any of these other languages? Why do we need scope?
Sir, maybe we can't remember so many names.
That is one reason. Exactly. That's very close to the answer I had in mind. The reason is that we want to reuse names. Yeah. Because there are so many nice names that, N or I or J or, you know, we don't want to remember 100,000 names. Whenever we are talking about one function, it is supposed to do something. So we would like to use some internal names for that function. And after that function is over, we just want to forget those names. And the function is only represented using its input arguments and its return value. Yeah, the internal details of the function. That is what we call black box abstraction. Yeah, the function is represented as a black box. Whatever comes into it and whatever goes out of it. We don't want anybody to see what is inside the function. Yes, that's why we have a scope for variables inside the function. Yeah, so we want we bring about scope so that we don't want to remember 100 names. At the same time, we don't want to mistake internal names for some other names. Yeah, internal definitions for some other names. These are the two reasons why we need scope. Okay, so now when in lambda calculus you don't have names, you have only lambdas. Okay, so if I have to have a function, this is a function. This is a function which takes two values, and I'll just finish in 1 minute. This is a function which takes two values and returns the average. Okay, now I could say define average to this one, and now average is a function which takes two values and returns the average. Okay, I'm mapping this name to this function. I can also map. So therefore, whenever I am writing some function name, this is equivalent to defining func yeah. So this is a nameless function. Lambda abstraction allows to build anonymous functions. Okay. All right. So I have exceeded my time. So I think these are the major ideas in 1.1 and 1.2. And for the next week, you will have to read 1.1, 1.2, 1.3. So that will be the first chapter, and watch the videos and either the videos or I have in that there is an audio lecture also. That is, I think a little more modern. The video lecture is from 1986. The audio lectures are from 2000. So the audio lectures I think will be useful. So next week, what we'll do is that we'll start out the week with a quiz on the first chapter, because we already know most of the ideas in the first chapter. So you'll have to read that. And then we'll start with a quiz on the first chapter. So prepare by seeing the lectures of which corresponds to the first chapter and the slides. Okay. And then, yeah. All right. Any questions? No questions? Anybody awake? Nobody's awake.
So will you be covering the models of evaluation from chapter 1, the normal order and the applicative order?
Yeah, that is in the 1.3 section.
So that is actually in 1.1 and lambdas is in 1.3.
Oh, lambdas is 1.3. What is? Yeah, so that I will cover in a later chapter. This call by name, call by value, call by this thing. That we will cover in when we come to that. Okay. So right now you can understand that as itself, because right now we are in substitution model, so it doesn't make much of a difference. Okay.
Okay,
Yeah.
sir.
Anyway, we will parameter passing and call by value, call by name, all these things we will see in detail much later on. Okay. And I will also add some notes for this from some books on this scope and typing. So you will have to read that also for the quiz. Okay. Any questions?
So what are the groups for?
What are the books for?
Groups.
What? What are what?
Sir, you have created groups in Piazza.
The groups for so one thing is that you did that will be used for discussion session, and another is that I want you to there are some 7 groups, so I would like you to go through, take one programming language and understand it in some detail and make a presentation about it. That's another thing. Okay. And possibly do a programming assignment in that, some representative programming assignment. You understand what I'm saying? So for instance, if you're going to take a programming language like Rust is a very popular programming language these days. Okay. And it is an improvement on C. It is used for system programming. And what they do is that they have some new mechanism called ownership, which actually allows you to detect a whole lot of runtime errors. And so I would like the one group to take up Rust and discuss Rust in some detail, and then show some code, for instance, a doubly linked list or a binary search tree or something which you have to implement in Rust and show the code. Yeah, and that has to be representative of the language. Hello? Hello?
Yes, sir.
Yeah. All right. So we will meet next Monday for the quiz.
Okay, thank you, sir.
Thank you. Bye.